can be defined using a definite integral. And now we're given the graph of f of t, and let's properly label this. This is t, this is y equals f of t. And now what does this graph represent? Well, the graph of f of t represents the rate at which water flows into a tank. And now it's measured in gallons, excuse me, not gallons per minute. Apologies for that typo. This should have been hour. So this is gallons per hour over time. Now, to compute part A, this graph, and that's going to give us, once we compute the inputs, that's going to give us the total amount of water that has entered the tank from 11 p.m. to whatever time we have now, whether it's midnight, 1, 5 a.m., 7 a.m., to whatever time. And now just some points to emphasize, F of t is the rate. It's a flow rate in gallons per hour. G is the amount of water that's accumulated in that amount of time. And now we're not going to use any formulas. We're just going to use geometry, which is something those of you in my class should be very comfortable doing by now. Okay, now we're ready to look at part A. G of -1, that's equal to the integral from -1 to -1 of f of t dt. Now geometrically, what is that? That's this point right here. It's basically a shape with no area. It's a little line, in essence, geometrically. So it doesn't have any area. So this is 0. We're not getting a region with area. Okay, so let's go ahead and look at g of 0 now. This is the integral from -1 to 0 of f of t dt. And again, this will give us the amount of water accumulated. So the amount of water accumulated from 11 p.m. to midnight. So let's look at this geometrically from -1 to 0, that is t equals -1, which is here, to t equals 0 here. We have this shape, which is a triangle. Its base and height are both 1. So this is just 1/2 times 1 times 1. And that equals 1/2. And now before I continue, though, there's something missing here. This is below the x-axis, or below the t-axis, excuse me. So since it's below the t-axis, this is negative signed area. That tells us it's below the x-axis. So I need that negative sign there. Now really what this is telling us is that from 11 p.m. to midnight, half a gallon leaked out of this tank. So the amount of water accumulated was, in essence, negative. And what negative tells you in these contexts is that you're losing something. You're not gaining it. So in this case, we lost half a gallon of water. Let's go ahead and look at g of 1. This is the integral from -1 to 1 of f of t dt. And I'm going to go ahead and erase what I worked on before. And now let's see. From t equals -1 to t equals 1, we end up with these symmetric triangles here. So that's this one here and this one here. Now we know the area of each of these is 1/2, but this one here has a signed area of -1/2, and this one here has a signed area of +1/2. So what this tells us is that well, we already know from 11 p.m. to midnight the water was draining out of the tank, and then somehow between midnight and 1 a.m. maybe someone came by and repaired this, and we know that the water started flowing back into it. And so by 1 a.m., the water that had been lost was replaced. But in general, from 11 p.m. to 1 a.m., not in general, what this actually tells us that from 11 p.m. to 1 a.m., what is the net change of water? Well, it's none. It's zero. We've accumulated no water. All right, I'm going to do one more with you, and then for the last of them, so that is, I'm going to do, I've already done this one of x equals -1, x equals 0, and now I'm going to go as far as x equals 1. Oh, I've done that one, excuse me. So let's go all the way to x equals 2. Let's do this last one. So g of 2. So this is -1 to 2 of f of t dt. So now let's look at these shapes. Well, I don't have to recompute the first two. I know that I have -1/2 plus +1/2. That's 0. So I still have that same 0 from before. And then what do I have here? So now when I go all the way to t equals 2, I'm going to accumulate this much more of this area here. I'm going to accumulate that much more water. And what is the area here? I see one full square and then a triangle that's half a square. So it's 1.5 or 3 over 2. You know what, let me write this as a decimal since that'll make more sense when we explain this in context. Now, what does this integral tell me? From 11 p.m. to 2 a.m., the net flow into the tank is 1.5 gallons of water. And in other words, we've accumulated 1.5 gallons of water. And I'm running out of space there. So H2O, that's the little bit of chemistry that I know, and I know that means water. Okay, now what I'd like you to do is pause your video, and I want you to figure out what G of 3 equals, G of 4, G of 5, G of 6, and G of 7. And then I want you to give me one general interpretation of each of these values. So you don't have to go as specific as I did here, where I gave you a very specific interpretation from 11 to midnight, from 11 p.m. to 1 a.m., from 11 p.m. to 2 a.m., but give me a very general interpretation that will explain what each of these 1, 2, 3, 4, 5 values for G that you are going to evaluate for me when you pause your video. Those of you in my class, remember I do check notes to make sure you've done this. And then in general, remember you can't learn math without doing math. So if you skip this, you're only cheating yourself. It's like going to the gym and standing on the treadmill and doing nothing, just like hanging out, watching TikTok on your iPad. Just turn on the treadmill and watch TikTok while you walk, you know? Do the same here. Please don't cheat yourself. All right, you should have paused your video and worked out what G of 3, G of 4, G of 5, G of 6, and G of 7, what value they give us. So let's go over these now. So I'll start with G of 3 here. Well, G of 3, we're going to take this area we already had accumulated here, and we're going to add to it this portion. And as you can see, I marked out the shapes. This is a triangle with height 1/2 and base of 1. 1/2 times 1 is 1/2 times another half, you get 1/4. So that's how I got that area. And this matches this triangle here, so they're the same. Otherwise, this leaves a rectangle with an area of 1/2. So what does that tell me? That this amount of area from 2 to 3, so the amount of water accumulated between 2 and 3 a.m. is 1.75 gallons. So all I need to do is add that to the previous value of 1.5 to get 3.25. Now the same goes for G of 4. Here, well, how much do we have accumulated? We have 1.25 accumulated. So we're going to get our previous value of 3.25. Add our 1 1/4 accumulated value to get 4.5. Now clearly between 4 and 5 a.m., that would be here between 4 a.m. and 5 a.m., this is just a square with an area of 1, so that tells us that 1 gallon of water accumulated at that time. So all we need to do here is add 1 to our previous value of 4.5 to get 5.5. So I'm going to pause here real fast and just remind everyone, this tells me that from 11 p.m. to 5 a.m., exactly 5.5 gallons of water accumulated in the tank. So remember, between 11 p.m. and midnight, it was leaking. Someone came by and fixed it, let's say. Or maybe it was supposed to leak out some water before it refills. I don't know. But for some reason, the tank was losing water. Now it's suddenly gaining water. And up through 5 a.m., it's gained a net of 5.5 gallons. Okay, let's keep going. What about G of 6 here? So for G of 6, this total deep blue area here, rich blue, is 1.5. So we're going to take our previous value of 5.5 and add a 1.5 to it to get 7. So 7 gallons of water have accumulated from 11 p.m. to 6 a.m. And now this last one here. So this orangish area is 2.5 units. So we take our previous value of 7 and add 2.5 to get 9.5. So let's talk about what we've actually done here. So what does this all mean? So really what we're working at is from 11 p.m. to X a.m. And I'm leaving it as X because X in our case, what I had you work out was either 3, 4, 5, 6, 7, but it can really be any value. So from 11 p.m. to X a.m., the resulting value gives us the amount of water accumulated in the tank. Please keep calm and math on.